All right, so looking at the warm-up, we have a list of numbers here, 13, 17, 21, 25, and 29. Do you notice a pattern in the sequence of numbers?
Yes.
What's the pattern? What are we increasing to go from one number to the next?
4.
We're adding 4. So we add 4 each time. So if I was looking for the next number in the sequence, what would that be?
33.
Perfect. 29 plus 4 would be 33. What about the next number?
37.
37. And then if we add another 4,
41.
41. And then the next number?
45.
45. Awesome. So this is what 4.6 is all about. Sequences. Adding one number to get to the next. All right, so we're going to be writing the terms of an arithmetic sequence. A sequence is an ordered list of numbers. Each number in a sequence is called a term. We can label that term as this symbol, that's a subscript, so a sub n. And it has a specific position n in the sequence. So if we look here at this sequence, the first position, or n, would be 1. The third position, n, is 3. So it just depends on the positions. This is a first, second, third, fourth, fifth. So not only are the numbers in our sequence important, but the position is important too. So in an arithmetic sequence, the difference between each pair of consecutive terms is the same. This difference is called the common difference. Each term is found by adding the common difference to the previous term. So our common difference, it could be positive, where we add the same number each time. Our common difference could also be negative, where we subtract the same number each time. So in example 1, we're going to write the next 3 terms of the arithmetic sequence. So in order to do that, we have to figure out what our common difference is. What am I adding or subtracting to get from one number to the next?
7.
Adding 7?
No, minus.
I'm subtracting 7. Because negative 7 minus 7 would be negative 14. So let's just double check. If I subtract negative 14 minus 7, that would be negative 21. So that works. That's our common difference. So our common difference is negative 7. Now this asks us for the next 3 terms. If I subtract 7 from negative 28, what would I get?
Negative 35.
Negative 35. Perfect. If I subtract 7 again, what would I get?
Negative 42.
Negative 42. And if I subtract 7 again?
Negative 49.
Negative 49. Awesome. So these would be the next 3 terms in our sequence. All right, let's look at B. What am I adding or subtracting here to get? Perfect. Adding 12. Just double check. 0 plus 12 would be 12. So I'm adding 12. So let's go ahead and find our next 3 terms. What is 24?
36.
36. What if I add 12 again?
48.
48. And adding it again?
60.
60. Awesome. So these are the next 3 terms in the sequence. You just keep adding your common difference each time. So looking at C, what am I adding to get from one number to the next? 0.4. I'm adding 0.4. Let's just double check. If I add 0.4 to 0.6, do I get 1? Yeah. So then let's find our next term. So I'm adding 0.4. What's 1.4 plus 0.4? 1.8. Awesome. Let's do it again. If I add 0.4 to 1.8,
2.2.
perfect, 2.2. And one more time. If I add 0.4, 2.6. Any questions here? All right, for the next one. So here we have fractions, but it's okay. We like fractions. What am I adding or subtracting to get from one number to the next?
1/4.
Adding 1/4 or subtracting? Perfect. We're subtracting 1/4. And then let's just double check. If I subtract 1/4 from 3 3/4, do I get 3 halves? Yeah, so we subtract 1/4 each time. So to find the next number, what is 3 1/4 minus 1/4? 3. Now let's do it again. To find the next number, what is 3 minus 1/4? 2 3/4. Awesome. If we can't do that math in our head, then just write it down. We have 3 minus 1/4. How do I subtract a whole number and a fraction?
By making the whole number a
What do I need when I subtract fractions? I need a common denominator. So how can I make 3/1 have a common denominator? I can multiply the top and the bottom both by 4, so make it 12/4. And then I just subtract the numerators together. So 12 minus 1 would be 11/4. Then all of our answers are in mixed numbers, so we would just have to change it into a mixed number. That would be 2 3/4. Perfect, because 4 goes into 11 twice with 3 left over. So if we can't just quickly see it in our head, then just write it down. We could also see that it will follow this pattern. Every time we take away 1/4, we get 3/4, 1/2, 1/4. So let's subtract 1/4 again to find the next number. Minus 1/4. What is 2 3/4 minus 1/4? 2 1/2. Perfect. Any questions here? So next, we are going to be graphing arithmetic sequences. So to graph a sequence, we let a term's position number in the sequence be the x value. So the x value is the position number. The term a sub n is the corresponding y value. We're going to plot the ordered pairs a comma a sub n. So the numbers given, these are our a sub n. These are our y's. Now we have corresponding x values, which are the position. So 4 is what term? First, second, third, fourth? It's the first term. It's the first number that was given. So my x value here would be 1. My y value is 4. So this point is 1, 4. Now 8, what position would 8 be? 2. That's the second number. So if I converted this to a point, what would the point be? 2, 8. Perfect. Makai, what position is 12? 3. Awesome. So Makai, what's my third point? 3, 12. Awesome. Marco, what position is 16? 4. So what would this point be? 4, 16. Awesome. Now we just want to plot these 4 points. So I kind of skipped this part because I made the table up here, so it's the same thing. But let's plot our points. So my first one is 1, 4. So I go to the right 1 and up 4. So there's my first point. My second point is 2, 8. Where would I put that? 2 to the right and 8 up. Awesome. Where would my third point be? Awesome. 3 to the right and 12 up. And then my fourth point would be 4 to the right and 16 up. So it'd be off the graph, but it's fine. We'll just put it up there. So this would be our arithmetic sequence. It's always going to be a straight line because you're always adding the same number each time. When we add the same number each time, that makes this linear. So this chart is always going to be linear. Your points on your graph are always going to be aligned. If you have 2 points here and another one down here, and it doesn't form a straight line, you did something wrong. So we gotta go back and think about it again. Do we have any questions here? Are we ready for the next one? All right, let's look at B. So I can make my chart up here with my x's and my y's. So the position is the x, the term is the y. What is my first term? So if my position is 1, what's the term? 3. Perfect. What's my second number? 6. What's the third number? And what's the fourth number? 12. Awesome. So these are our points. So let's go to our graph. How would I graph 1, 3? To the right 1 and 3 up. How would I graph 2, 6? To the right 2 and 6 up. What about 3, 9? To the right 3 and up 9, and 4, 12. To the right 4, up 12. Perfect. So that would be our graph. All right. So the numbers that are given here, are these my x's or y's?
Y's.
These are my y's. So 1 is in what position?
1.
The first position. So what would my first point be? 1, 1. So when the position is 1, my term was 1. What's in the second position? 0.8. So the position's 2. The term would be 0.8. What's in my third position? 0.6. And the fourth position? 0.4. I'm going to change the numbers on my graph and just make them decimals. So this would be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.10. Nope, that wouldn't make sense. I got to do it on the y-axis because my y values are decimals. I'm going to change these. It's be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. This would be not 0.10, it'd be 1.0. 1.1 and 1.2. So I just changed our y values to make our graph a little bit easier to see when I plot these. So to plot the first point, I go to the right 1 and up 1. So that would be all the way up here because I made this 0.1. So these are all the decimal values. For the second point, how would I graph that one? 2 to the right and up 0.8. Perfect. For the third point, where would I go? To the right 3 and up 0.6. And the fourth point? Awesome. To the right 4 and up 0.4. So that would be our graph. So example 3, we got to see, does the graph represent an arithmetic sequence? So we got to look at our term, the term position, and the number. We want to see, do our y values increase by the same number? So to go from 15 to 12, what would my common difference be here? Minus 3, yeah. So then to go from 12 to 9, is that minus 3 also? Yep. 9 to 6? Yeah, minus 3. So do you think these graphs represent an arithmetic sequence? Yes. They're also always going to form a straight line. Sometimes it won't be as easy to tell just by seeing if it forms a straight line. So you can always just find your common difference and it'll be the same thing. Any questions here? All right, let's do the next one. So am I looking at the x values or the y values? The y. The y is the term number. So let's see, am I increasing or decreasing? Increasing by how much?
+2.
So plus 2. If I add 2 to 4, do I get 7?
No.
What would I have to add?
3.
Add 3. What would I have to add to 7 to get 11?
4.
Is this an arithmetic sequence?
No.
No. Because you're not increasing by the same number. You don't have a common difference. So if it's a different number that you're adding to get from one to the next, it's not an arithmetic sequence.